In our next session for FTD next generation IPS, we will take a look at two main components that make up our intrusion policies. It is going to be variables and roles. A stored variable can be compared to an object which is more of like a container for a certain value. And in case of Snort variables, it is going to be specifically IP addresses and port numbers, what we will be referring to through the variables. And now the reason that this component is going to be critical for Snort policies is that most of the roles available on FTD are built based on those objects instead of individual IP addresses or port numbers. The reason it is done like this is that it allows you to use the same role set in any network without having to modify IP address information. So since the roles will be referring to variables, it's going to be logical just to change the variables themselves, this way tuning our roles to a given environment. Those variables, as we will see in the next session, they will be located under objects. So we will be able to tune those variables. We will be able to create multiple variable sets or maybe just tune the default one. Then now the variables themselves, they can be divided into three categories. We have those objects that define our networks, like for example HomeNet. We have variables that define servers. Those will be referring to addresses of our web, FTP, or possibly DNS servers. And we have variables that will be used to define port numbers on which our servers are listening on, like for example ports for our web servers. I will be emphasizing this over and over again. The definition of variables, the configuration of variables is going to be critical to any type of next generation IPS deployment. If you misconfigure this component, it could potentially blind your IPS system, rendering it pretty much unusable. Now, the two most important variables you should always tune, it is going to be the HomeNet, which is what defines your protected networks, and it is going to be the external net variable, which is what defines your suspected network. Okay, so these two is what you will have to configure with accurate IP address information. The reason why they are critical is that most of these Snort roles are written using external net as a source and HomeNet as a destination as part of the role's header definition. So this normally means that Snort is only going to inspect communication flowing in this direction, from external to HomeNet for most of the roles, not all of them, but I would say like maybe 90% plus of roles use these two in the header definition, which is, as we will see later in this session, what describes what communication we want to look at. So normally the roles will be looking at communication from external ranges to HomeNet subnets. And what some people do is that they set the external net variable to be anything but HomeNet subnets. And this might work in certain scenarios, but in some others it won't. So the problem we could potentially run into here, I'm gonna say that we have a firepower threat defense unit which is connected to internal subnets. And we will say that they both use private addresses. This is gonna be my subnet 1, this is gonna be subnet 2. And we will have a connection to the outside, to the internet, which, as we know, uses public IPs. This is going to be inside 1, this is going to be inside 2. Okay, so if you were to set your HomeNet to be subnet 1 and subnet 2, and then you would say that your external net is everything else but HomeNet subnets, which is gonna point to public addresses in our case. It would mean that only the traffic that is flowing from the public addresses two private IPs would potentially cause your most of your Snort rules to trigger. Because remember, the rules are built, most of them are built in this direction, from external to home net. So since my external variable points to public addresses and my home net points to private ranges, we would be only able to detect attacks coming from the internet destined to first or second subnet in this design. So that type of configuration is going to generally work for north-south communication, like when you put FTD on the internet edge. But how about if you are looking at the east-west traffic? Or in other words, internal communication, like from S1 to S2 or vice versa. In this case, all rules written using these two variables from external to home won't trigger. Why? Because subnet 1 to subnet 2 is private IPs only. And the rules are looking at public IPs as the source. This is not going to work for east-west traffic. Okay, so what is going to be the solution to this problem? How would you actually want to configure the variables? You would definitely want to be very accurate with the home net setting. You would want to include all subnets that you want to protect, so all internal networks, all trusted networks. Plus, you would also include your public addresses, the public ranges that you own. So this stuff is going to be allocated to the DMZ in most cases. So a bunch of private IPs plus all public addresses that belong to you, to your organization, and then you would leave the external net variable as anything. This is actually the default setting for this one. As a result of doing that, no matter if communication is sourced on the internet or in one of your protected subnets, internal networks, it is going to match the inspection rules. Okay, in addition to that, you would also want to tune the server and port variables, especially for stuff like DNS and HTTP. If you have a lot of servers, maybe it is going to take too long to get those addresses, or maybe those addresses often change. You can also set the server variable to point to home net. This is also going to work for any situation. Now with ports, you want to be specific. Of course, if your servers listen on port 8080, you want to add it to this variable. If this is going to be a different port, put it here as well. And there is also another way how you could potentially tune the home net and external variables. Like if you wanted to point external to not home net, or just anything but home net, you could potentially come up with two variable sets. And then each of those two variable sets would be associated with one access control policy. So I would have my variable set 1 that I would use in my access control policy 1. I would have a different variable set for another policy. And now in this policy, I would say that this is for inside to outside, or just outside to inside communication. And in this case, I would be able to use this setting. And in the second policy, I would say that this is for internal stuff. So I would keep using this option. Okay, of course, because the second option, when you set the external net to any, is going to work in any case. Most people, they tend to use just one policy, just one set of variables. It's not recommended to complicate your policies unless you really have to do this. In the second portion of this session, I would like to focus a little bit on the rules, on the rule structure. Every single Snort rule consists of two components. It is going to be a header and it is going to be a body, where the header is generally used to specify what communication we want to look at, just what packets we want to inspect. In this case, we will be pointing to layer 3 and layer 4 information. So we will include information about IP addresses, source and destination, port numbers, source and destination, protocol, and here is also where we will specify direction of the flow. Like from the source to the destination, maybe the opposite, or maybe both directions. And this is where we will also configure an action that is going to generally tell the Snort engine how to handle the packet that we match. In most cases, you will use the alert action, which is how you will generate events and also log details of the packet. Another very useful one is going to be pass, which is how you make exceptions to the inspection. So pass rules will be processed first before alerts or any other types of rules. You can have a broad rule configured with alert, and you can build specific rules with the pass action. Okay, we can turn the rule off. We can generate events only, and we can finally drop and generate events. So this is going to be used in the inline deployments only. It's only the inline mode what gives you the option of dropping the offending packets. Okay, then the next portion of the rule, this is going to make our body, which is also sometimes referred to as rule options. And this is where we will be more specific with our conditions. This is exactly where we will describe the attack, or just the specific information, in most cases from the payload of the packet, that we want to look at. And those conditions, they will be written using a bunch of keywords, where each of the keywords is gonna contain one or more arguments. This is how we will define our patterns to match. And finally, when we have a match here with this specific condition or with specific conditions, this is when you will eventually take the action that we configured in the header of the rule. This portion of the rule also contains a message that will be displayed when we have a match. Right, so let's now take a look at an example of a rule. We will first start with a header. We see that it's the action, what comes first. Then it's going to be the protocol. We also specify our variables, or maybe IP addresses if you want to use addresses instead of variables. This is going to be source IP. What's over here? This is going to be source port. What follows? Then we've got the direction. So in this case, it's from the source to the destination, from the left to the right. This is our destination IPs, and finally destination port numbers. As you can see, this portion of the rule is actually pretty easy to decode, which is not necessarily the case with the body. The body is a little bit more complicated. It's all about knowing those keywords and arguments. This is mostly to define the attack that we want to detect. Plus, there are going to be some other options, other keywords that you will use to provide some general information for the rule. Like, for example, a message to show when there is a packet that matches the rule. And now, in terms of the specifics of this body language, notice that the body portion always starts and ends with parentheses. And since in general it is meant to be written using just one line, if multiple lines are needed to define the body, we will have to separate them with a backslash. Let me go back to the previous example for a second. We see that the body starts over here and ends with another parenthesis, and we've got those backslashes that separate the content of the body. Now the other thing is that keywords, they end with a colon, where each of the keywords is going to be followed with at least one argument, and here the last of the arguments is going to end with a semicolon. And when multiple arguments are defined, they will be separated with commas. We've got another example. The body starts here, it ends over here. Message is what makes our keyword, and then this is what makes our argument. It ends with a semicolon. In this case, it's just one argument would be used. Then flow is what makes another keyword. It ends with a colon. And then toServer, this is going to be our first argument. And then established is what makes second of the arguments. They are separated with a comma, and the last argument ends with a semicolon. So it is definitely useful to remember about those argument and keyword separators. It's going to make a process of building the rules much more easier. Okay, the rules themselves can be uploaded from a text file. So we can use a notepad to build the rules, or a much more user-friendly method is going to be to use the rule editor on the FMC's GUI. This is what we will actually focus in our next session. To finish, I'm going to quickly look at more important keywords and their arguments. The content option, this is what you will be using probably the most. This is how you will describe the string you want to look at in a packet. And the content can be defined using ASCII or hex characters, or maybe you will be able to specify both types of characters as your string you want to match. Now, the key thing to remember here is that your hex characters must be surrounded by a pipe. Like in an example below, we've got 28 between the pipes, and then we've got C, which is ASCII character. So this is going to be hex, this is going to be ASCII. Then we've got another pipe, 29 in the pipe, which makes a hex character, which is then followed by /, bin, / and sh. So this is all ASCII stuff. So we mix two types of characters in a single string, where the result of that is going to be this, a string of characters what you want to match. Hex 28 and hex 29, this is it's just parentheses in ASCII. Okay, so content is what makes our keyword. And now individual arguments that we can also include for this keyword, it is going to be, for example, no case. Like if you want to make the lookup case insensitive, you can specify the offset from the beginning of the packet where you want to start to look for the defined string. You can specify how long into the packet since the beginning or the offset you want to look at. And then if you plan to match the string multiple times, you can also specify what is going to be the space between the subsequent portions of the packet you will be inspecting. Another example, PCRE, another useful option. This is what we will use to specify regular expressions, and those regexes will be using Perl compatible language. What's going to be important to remember about this one is that our regex must be enclosed within forward slashes. So you will always start with a / and you will end with a /. And then you can use those regular meta characters, like for example a pipe or a dot, to build your expression. It is also possible to use modifiers that will follow the expression. Those options from lowercase I to uppercase Y. Okay, what this stuff actually means, the easiest way to figure that out is going to be to take a look at that in the documentation. And this is also my recommendation for other keywords and other options that I didn't show you here, because there is much more than just these two. First and foremost, use the doc.cd to figure out the right syntax, or possibly also visit the Snort documentation page at www.snort.org. This is another great source of information about Snort rule syntax and Snort in general. Maybe let's start with this one. Let me show you this from the main page. There is the document section here. And probably what you want to take a look at is going to be the user's manual. I would focus on this one the most. The infographic, this is just a quick recap on the role structure. They show you the example of a header, and then we've got a body for this role, and they explain what those different options actually mean. Okay, now the manual itself, as you can see, it's almost 300 pages long. And this is where you can get information about Snort engine, about the different components of the engine, including elements like preprocessors, like the event processing stuff, performance profiling, a very specific information about the technology. The section I would be probably looking at as you plan to build the signatures, it is going to be section 3, writing Snort rules. So they will explain you what those different keywords mean. They will show you examples as how to use them. They say addresses, direction operator, protocols, rule options, and then we've got those general rule options like message, like identifier, and there is going to be those payload detection keywords. Now, in case of Cisco's documentation, we will go to the FMC and we will take a look at intrusion prevention. Let's take a look at 6.1. Down to intrusion detection and prevention. And I would be looking at this portion of the document, the intrusion rules editor. So this one is going to show you information similar to what I discussed in this session. It is going to break down the structure of the header. And then there is also going to be a section for the keywords and arguments. So many of them you can actually look up in the doc.cd. There is this content. There is this, let me look for PCRE. So content and PCRE, these two you probably want to focus the most. For regular expressions, it shows you the syntax and shows you the options. It recaps on the different parallel regular expression meta characters, like what's the dot, what's the meaning of a question mark, what's the meaning of the caret sign, and so on. And then it will tell you about the modifiers. Like in this case, we see that lowercase I. This is what you would use if you want to make the regex case insensitive. So pretty useful stuff. Cisco's documentation and part of the manual on the Snort website. It's a recommended and really good read before you start writing your own signatures.